we all are aware, today is the session of Dr. Rashid Hussain, and I'm giving the brief introduction of Rashid. He is currently working as an associate professor and head of the MS program in security and network engineering at Innopolis University, Russia. He is also the director of networks and blockchain lab, and as well as the director of Institute of Information Security and Cyber Physical Systems at the same university, Innopolis University, Russia. He is a senior member of IEEE, member ACM. He also serves as ACM Distinguished Speaker. He received his MS and PhD degree in computer science and engineering from Hanyang University, South Korea in 2010 and 15. He worked as a postdoctoral fellow at Hanyang University, South Korea from March 2015 to August 2015. He also worked as guest researcher and consultant at University of Amsterdam, the Netherlands from September 2015 till May 2016, and then worked as the assistant professor at Innopolis University from June 2016 to December 2018, and currently he is serving as the associate professor over there. He serves as the editorial member for various journals, including IEEE Access, Internet Initiative, Internet Technology Letter, Wiley, Cluster Computing Journals, Springer, and many more. He also served as a chair technical program committee member for IEEE, ICC, IEEE, VTC, IEEE, VNC, and so on. He is a certified trainer for instructional skills workshop. His research interests include information security and privacy, and particularly security and privacy issues in vehicular ad hoc networks, vehicular clouds and vehicular social networking, applied cryptography, IoT, content-centric networking, cloud computing, and blockchain. Currently, he is working on carpooling and blockchain technologies for resource constrained environment, ML and DL in IoT security and API security. And today, he is going to speak on AI and the role of artificial intelligence and machine learning in cybersecurity. We welcome you, Dr. Rashid. Thanks for giving us your precious time. Thanks a lot. You can start, please.
The agenda for today is that I'll talk a little bit about cybersecurity, because I know there are students over there, there's some faculty members, so I'll try to concise my talk, which would be beneficial for both students and faculty members, who can get something out of it and see where we can apply or where we can select the research areas in the future. Then I'll talk a little bit about innovations versus security. What is the relationship between them? And I'll describe a little bit about the attacker mindset. And then we will talk about sophistication in the threats. Then I will move towards machine learning and deep learning, and in the bigger picture, artificial intelligence in cybersecurity. How can we use that? And I will also spend a little bit of time on adversarial machine learning, which is a very emerging field in artificial intelligence. And then at the end, we will talk about takeaways. So as Dr. Shali already talked about me, I'm currently working as an associate professor and director of Networks and Blockchain Lab, and also the director of an Institute of Information Security. I serve as a member of different committees, different groups. I have some certification in both teaching, pedagogical trainings, and some other training for instructional. And I also contribute to the research community in different committees and different editorial boards as well. So I think you already know about my past, what I did and where I did, so I will not spend much time on there. So we'll dive right into the topic for today. I'll start briefly about security. Whenever we talk about security, there's some misconception between people. And whenever you mention the term security, the thing that they understand is that it's just, for example, hacking, stealing your password, or logging into your account in illegitimate ways, and so forth. But we have to look at the problem from two different perspectives. First one is the academia, and the second one is industry. If you talk about security in academia, it means that there's a pyramid that we call CIA, not the CIA that you can think of, but we have our own CIA, which is confidentiality, integrity, and availability. These are the three main building blocks for security. Confidentiality, as you may very well know, that it is like you want the information to be delivered to the person for him it is supposed to be, and nobody else should have that information. Second one is the integrity. The health of information or the data, whatever you're trying to send or communicate, should be intact. So it shouldn't be polluted. Third one is authentication. Authentication means that, well, if you want somebody to have information, only that person should have information. And what do I mean by it's family and friends? Because authentication includes authorization and access control and these sort of categories as well. And then becomes privacy. So privacy is again very important. It's not only the integrity and confidentiality, but privacy as well. Sometimes we don't want our information to be shared with people. That is why we need to have privacy as well. But these are the things that are very dry in the sense that we have been discussing these things for ages. And if you're in academia, these are the things that you will have to take care of and you will have to bump into on a day-to-day basis. And the list goes on because there's so many other things than what I just said. But if you go to industry, then the story changes. How does the story change? In industry, if you talk about security, the first thing they will do and they will consider is the types of attacks. For example, DDoS attacks, denial of service. I mean, if somebody is going to crash your system, somebody is going to crash your um, computer or server, what they can do is that they can send you billions of requests that cannot be handled by that server. So eventually your system will crash if it is not fail safe. Second thing that industry is concerned about is the risks. So what resources are at risk and what can the industry lose or the company lose and so forth. And then there's safety and then there's hacking and then there's a bigger picture for whole company or whole firm. So you can see that there are two different perspectives from academia and from industry. So you will have to consider both of them together to talk about security. Okay. Well, if you think closely, these things are not very, I would say, not related because they're somehow closely related. How? Because when we talk about authentication authorization, then the attacks that can happen without the presence of these security parameters can can way these two are connected. When we talk about authentication, authorization, whatever we do in academia, the applications of these, misuse of these can be applied in the industry, and that will result in certain types of attacks, the sort of which we already talked about here. So they are not very like different things, but the mindset and perspective is different. So we have to think from that perspective. So there's a doctrine for cybersecurity. Once again, I'm going to do comparison. There's some old thinking, old school thinking, and then there's new world thinking. Well, the world is changing as we change every day, so we have to look at it as well. So if you talk about old thinking, the old thinking says that you have to protect information, you have to protect content, and you have to protect network. Just think about it. For the people who are already might be working in security, this is what we are doing right now, right? So protecting information. Well, what exactly we are doing for that? For example, encryption, right? And protecting content and the network. So firewalls and IDSs, IPSs, and so forth. And we're also isolating the network that is critical, that is security critical, and we are protecting that network. So this is kind of old thinking. Why do we call it old thinking? Because the priorities have changed now. How? Now we have huge amount of services and applications. For example, mission. Well, we have missions that includes, for example, services and different applications. Now, the evolved thinking is that forget about information and forget about content and forget about network. Think about the service and application. Well, once again, in a way, they are a little bit connected, but the mindset or the approach can be different. And second one, it is not very important or crucially important to secure something. Rather, another important thing is to be fail safe. So how can you operate through failures? Like failures can happen, you cannot stop it, you cannot 100% stop it, but you have to think how do you operate if you fail, right? And third one is there's a context important. Whenever you run services or applications, you have to take their contexts into consideration. For example, if in the futuristic applications we consider IoT, Internet of Things, autonomous cars, and other very complex networks, then the context is extremely important. Why? Because we are living in an integrated world. In one context, one kind of security requirements will be there, and in another context, another security requirement will be there. So you have to keep track of the context as well. So we have talked about true thinking, evolved and old thinking. But like these days or in present scenarios, we are focusing on the evolved thinking and we are talking about services and applications rather than the original protecting information, content, and network stuff. Okay. Then there's other bad news. I call it a bad news because it's kind of puzzle when you look at it. If you're talking about, let's say, CIA, confidentiality, integrity, and availability, then there are other rivals. We already talked about it, but I will explain it now. Privacy. Well, if you talk about authentication, if you want to know somebody to reveal identity, and at the same time you do not want to reveal your identity. Now these are in conflict with each other. So how much
जी जी सर
authentication you
अभी
want?
मैं कर
How much authentication you want,
सर
and
इसमें
how
आ
much
गया चेंज रोल टू प्रेजेंट ओके
privacy do you want?
ठीक है ओके सर डन
A lot.
ठीक है सर ठीक है
Okay. And then there's usability. Hello, Shali.
नहीं नहीं मैंने कुछ भी नहीं
I think you should mute. I can hear you,
हाँ जी
Shali.
ठीक है सर
Okay.
फिर मैं कॉल कर दूंगी ठीक है सर, ठीक है सर, ठीक है
I
सर।
can hear you.
ओके, थैंक
Okay, so there should be trade-offs between authentication, integrity, and privacy. Those trade-offs will be defined by the experts and certainly by rules and regulations, the laws and those kind of things, but there will be definitely trade-offs. So we have to consider them as well. There's no perfect privacy. There's no perfect legitimacy in authentication and so forth. There could be, but at the expense of others. Once again, the application context is very important as well. But if you consider it in a broader picture, then there's privacy, and the outer wall is what we call security. So you have to you have to provide privacy at the inner circle, and then you have to provide all the security requirements from the outside. And then there's some very middle ground, very fine and thin red line between these two terms, security and productivity. I often give this example. If you have very sophisticated idea, top-notch idea, and you take it to the CEO of your company, you know what he will say? The first thing he will ask you, how much will it cost? Because it requires money. And this is what scare the hell off these big shots and CEOs of the companies. They will never agree to you. As a security architect, people will have very hard time in convincing people that security is really important, right? So if you're from the security side of this wall, well, you will say that let's not do this because it will do harm to company or firm or this and that and so forth. On the other side, productivity, for example, if there's some solution, let me give you an example. There's banking mobile app which is being developed, but it is not secure. As a security architect, you will be yelling at them to don't do it because there will be attacks as a result of it, right? But on the other side, from the productivity, there will be business people, and they will be saying that, well, I don't want to lose my money on this, so let's build it and cash out some benefits out of it. Well, we will see. Our children and grandchildren can then, make it secure. So this is how it works. And there's very fine and thin red line between productivity and security. Till now, this is all philosophical discussion, but it is extremely important to know what exactly do we mean by cybersecurity. Well, then when we talk about or when we know about the limitations or the pitfalls or the thin red lines between different terms, then we have to move on to some dilemmas. We have huge amount of resources these days. Imagine buying a top-notch computer back in 2000 and today in 2020. How about the cost? How about the resources? Well, I think everybody has a laptop with the 16 gigs of RAM or 8 gigs of RAM, which was unimaginable 20 years ago, right? And we have sheer amount of data, which I will show you in a moment. We have very sophisticated attacks, which I will talk about a little bit. And then we have to get into the head of these cyber attackers, and we need to understand what they intend to do. So the volume of data back from 2017. Let's see what was happening in 2017. Well, in 2017, YouTube, in YouTube, there was 48 hours of video watched every minute. Okay. And Google, 2 million searches queries every minute. Apple was receiving about 47,000 application downloads. And so forth. You can look at the chart and you can imagine what was happening every minute. This is humongous. Like, how do you How do you take care of this data, this huge amount of data, okay? And how do you process it and how do you use it? And this was back in 2017. How about 2020? Well, in every minute, there are 4.1 million search queries, okay? And 4.7 million videos viewed every single minute. And 19 million texts were sent in just text messages, and 59 million messages sent over both Facebook and WhatsApp every 60 seconds, every minute. So just for a moment, think about the data that is produced every minute in the entire world. How do you take care of this data? How do you process this data? How do you use this data? So this is what I meant about the mammoth resources. Now let's get into attacker's mindset from the experience, from the literature, from the incidents. We can see what attackers want to do. They could be militaries. For example, they want to use these attacks in cyber weapons, robot soldiers. We can see these things are not science fiction anymore, and we can see them. Second is governments. Well, they could establish control over people, monopolies, and better management of their assets and some other things. There could be corporations. They want to get ahead of other people. They want to go into competition with their rivals and so forth. And then there's hackers. They can steal information for money, or they can steal information as a result of some incidents. They can do it for other people. They can do it for a lot of other reasons. Well, there are these doomsday cults. They want to bring the end of the world. Trust me, there are maniacs, and there are people who think that they could bring the end of the world through by the comfort, like from the comfort of their chairs and comfort of their keyboard, and they're psychopaths. They want to add their names into history books, and there's some geniuses, trust me, and they're criminals. They do that for criminal reasons. And then there's another very important category, the people who just do it for fun, which is another definition of fun, to play with critical infrastructure or somebody's life or whatever you call it, but they just do it for fun. So this is the very major classes of the attacker mindset. Innovations versus vulnerabilities. So how would you call the betterment of innovation versus the vulnerability it brings upon? For example, in today's connected world, we have Internet of Things, where every single thing in your household could be connected to internet. But wait, the idea is spectacular. Idea is really good, but is it good enough for your security? Because these tiny things that you connect to internet, they're resource constrained, and they are the literally butter and bread for the attackers, because they can attack very efficiently by using this stuff. Okay, so connected world opens up the world of vulnerabilities as well. Complexity. Today's internet is enormously complex. It's very much complex. You cannot even start to imagine, with the proliferation of, let's say, cellular internet and all other internet components that we have, it becomes increasingly complex to deal with. And that complexity give edge to the then their demands from citizen or users. They want to have application that keeps track of, let's say, their movements. They want to have an application that gives access to their car. They want to have an application that gives access to, let's say they want to use their phone as a remote control for TV because they're too lazy to get off the sofa and grab the remote control and operate it, and so forth. There's so many other demands from the citizen. So you have to take care of that as well. And then there are sophisticated attacks, really sophisticated attacks. What kind of attacks? For example, malware. Malware is something like very sophisticated code that runs itself in an environment and do some harms. For example, give control to people. How was the numbers that originated till 2018 in malware? In 2018, it was 0.35 million, and they're like increased a lot. Okay, there's so many, and every month. So you can see that if you look at the graph closely, there are like few millions every month, and something that we called 0 day means that there are new malwares coming every single day that were not found before. So if you found a malware, you can provide a solution to that. But what about 0 day malware? 0 day malware means that it was not found before. It just got found, let's say today. What do you do about that? If you're working on today's malware, tomorrow there will be a million more. So what exactly do you do about it? Do you think that the current mechanism that we have for, let's say, malware protection are enough, or we need to have something very sophisticated one, or think out of the box? Okay. And new malware, which I told you about. So every month, for example, in November 2018, because I had the data till up until this time, so every month 8.23 million, 8.23 million new malware attacks. Just imagine the severity of the situation. And one of my favorite, which just made me stunned. I'm not sure if you, some of you can read Korean language, but this is from Korean language. It's called mire. Mire. Mire in Korean means future. It was a DDoS attack, distributed denial of service attack, few years ago, and it literally crippled the internet temporarily for the whole world. It was 600 gigabits per second or 1 terabits per second attack on two DNS service providers. You know that our whole internet is based on DNS service, right? So what it did is that it targeted two services, OVH and Dyn, and they literally crippled down, and it brought down the whole internet for some good part of the world. How was it done? You would be amazed if you, I would really suggest you to go and read the story of Mire. There was a undergraduate student I guess it was, yes, in the United States. He was just sitting in his home, and he thought about the IP camera that we have, CCTV. Some of them, they're not secure, right? What he did is that he wrote a code, okay, to find the cameras that are not secure, who does not implement any security mechanism. He collected all of them, like millions of them, and he made those millions of cameras to send some kind of request to these services at the rate of 600 Gbps or 1 Tbps. It is huge. It is beyond your imagination huge. These two services. And it was done right from the chair of a drawing room of an undergraduate student in the United States. So it is not like very hard to think about something very sophisticated with something very new and very small. So who would think that IP camera that are not secure can do such harm to your whole internet? Okay, this is the graph. Here you can see that the people who were affected from Mire. So all these pops up that you can see that here the services were temporarily exhausted. Okay. Then there's ransomware. I'm sure some of you, I had an experience with my cousins. They got such messages. I'm not sure we have a lot of attendees here. If you ran into this kind of problem as well, which is ransomware, it means that somebody accesses your computer. If you click on a wrong link, you can have such screen which tells you that give me, let's say, 100,000 rupees. Only then I will decrypt your computer. Otherwise, your everything is encrypted. And the key is with attacker. Unless and until you send them Bitcoin or you send them, you transfer them ransomware, they will not decrypt it for you. Okay, so this is another form of malware. We call it ransomware. There's a cybersecurity economy involved as well. A huge amount of revenue generated for it, of course, by these people and attackers, but there is economy involved in that as well, in ransomware. Lots of money is being stolen from people by using these ransomware. There are, for example, automated adversaries. Okay, automated adversary means that you don't have to do anything. All you have to do is to write an intelligent, sophisticated code that could act on itself without any intervention. Okay, and in 2018, Ponemon they reported that there's a huge increase in fileless attacks. Okay, fileless attacks is a nightmare. Why? Because even if you don't click something, you can get attacked. So this is the new frontier that you have to fight, like the people who are working on security to fight. Okay, so just laying the groundwork. Now we come to the artificial intelligence. So by now you should have an idea about what we are dealing with, how much data we are dealing with, what level of sophistication we are dealing with. Then we have to think of something out of the box. As I told you before, you have 8.3 million new malware every day. Do you want to sit and spend days to, to reveal what kind of malware that was, what kind of bad code that was, what exactly did it do? Did it access your system file? Did it access your root login? Did it access your, let's say, financial details? What exactly did it do? So will you do that for 8.3 million? Even if you have billion workers working on each malware every day, well, congratulations, you cannot do that. Why? Because next day you will have 8.2 million others. So is there any other mechanism that we can deal with? I'm just giving you one example, which is malware, but there are other examples as well. Well, here's where artificial intelligence come into picture. We have artificial intelligence, which is the capability of imitating intelligent human behavior. So if you can put that into computer somehow, of course we cannot do it 100%, we will see. Sorry, but we can still imitate it somehow. And then there's the subfield of artificial intelligence, which is machine learning. Means that capability of learning without explicitly programmed. Okay, so if we can find this fine-tuned methodology in computer, we'll be very lucky to stop the machine learning work. Just an overview. There's a learning part. You have to provide something to learn from, and then from that learning, you perceive something. And if you perceive something, you can, if you perceive enough, you can take decision on that. And that decision takes you to autonomy, means that you do not need any intervention, but you can decide on your own and you could be autonomous. Okay? What is machine learning? If you talk about very abstractly, I already told you that it's capability of learning without any explicitly programming involved. But in other terms, it is what we call automating automation. Okay, if you're able to automate the automation itself, this is what is achieved by machine learning. And to make you understand more, it is getting computers to program themselves. It looks very stupid, but this is what it is. Well, writing software is a bottleneck always. There could be software engineers here. There's always errors. There's always room for errors. Why? Because we are human beings. We are prone to errors, right? But then why don't we let the data do its work and make it correct for us? Okay, so that is the beauty of machine learning. So to make it more easier for you, there are two kinds of paradigms. First one is traditional programming. These are the figures that I love most because it tells you the whole story. You have data and you have program. You write a hello world program in C language. You feed it into computer and you have this beautiful output, hello world, right? This is what we call traditional programming. What happens in machine learning is a little bit the other way around. How? You provide data and you provide output to a computer and it gives you a beautiful program against that. So if you think about it, some kind of learning could happen here. Okay, so this is the major major easier definition of a machine learning. It is more like gardening. Well, how? Because you have seeds that are your algorithms, you have neutrons, that is your data, you have gardener, that is you, and there are plants, which are your programs. Those plants grow in the garden. So you can look it into that perspective as well. So in a nutshell, there are tens of thousands of machine learning algorithms. There are hundreds of them every year. And every machine learning algorithms has basically three components. First is representation, second one is evaluation, and third one is optimization. Representation means that, for example, if you have data, how exactly do you represent it? And how that algorithm will be evolved. And third one, to make it better again and again and again, based on the experience, how do you optimize it? So these are the three basic presentation of, the components of machine learning. There are different types of learning. I'll just go through it. Personally, I'm not an expert in, very much expert in machine learning, but I'm looking at learning from the security perspective. So I know the bit that is very important for security. Okay. First one is supervised learning, means that you need to have training data, okay, and you need to have desired outputs as well. And from that, the algorithm can learn. Second one is unsupervised learning. The training data, it does not include the desired output, so it will do it itself. Third one is semi-supervised learning. Well, there are very few desired outputs included into the training data. And the recent one and more influential one is reinforcement learning. So learn from mistakes, like this is how our children and this mistakes and they learn with rewards. So in the computer world, we call it a reward, and in the real world, we call it some kind of learning from your own mistakes. Okay, so reinforcement learning is being reward giving to people who do good job, and giving penalty if they do not do the desired or good job. I'm being very careful with words because sometimes we use it in the computers and sometimes we don't use it. So forgive me for my wordings, being not the expert in machine learning. This is from our recent paper that we published in Surveys and Tutorials, which was the role of machine and deep learning in cybersecurity. So you can see that we have supervised, unsupervised, semi-supervised, and reinforcement learning, and then all the classifications involved in that, and the applications of these methods, for example, predictions, weather forecasting, market forecasting, and so forth. There's so many other applications that it could be used in. Now, what are the forms of artificial intelligence? First one is applied artificial intelligence. Well, the good thing about applied artificial intelligence is that it delivers exceptional performance for a specific task. For example, malware detection, let's say, object recognition, malware detection in cyber world, object recognition in, let's say, autonomous driving. If the car is driving itself, you want the car to recognize what is in front of it. Is it another car moving? Is it a person crossing the road? Is it a bystander? Is it a tree? Is it what? So that object recognition as well. Apple Siri, it's a very specific task. So that could be done um, by this applied artificial intelligence. And it is delivered using very well-known machine learning techniques, for example, deep learning, neural networks, natural language processing, and so forth. And second class of artificial intelligence is what we call artificial general intelligence, which means that it's full range of intelligent tasks, at least as good as human, or one should learn how to do it. Okay, so we also call it cognitive artificial intelligence. So these are the two, and then there's a third one, which is what we call strong AI. It is same as applied artificial intelligence, but with conscience and self-awareness. This one is the hardest to achieve, but well, we are still very far away from applied general intelligence and strong AI, because whenever this term, this beautiful term conscience come into picture, this is the beauty of only human being to have it, others not. I'll share my experience with you. I ran into a problem with the trolley problem. Trolley problem is the problem probably many of you already know. When I was working on autonomous cars, I had to discuss this problem, which says that, okay, if your car is driving itself, autonomous car, and there's a bus that contains like many people, and there are two bystanders, there are two pedestrians, okay? And the car has choice to either hit the people on the sidewalk or hit the bus, killing, God forbid, 15 people or killing 2 people. What should it select? Killing 2 people or 15 people? We could talk about it for hours. There's no easy answer for it. But, well, we have to avoid such situation, but sometimes you cannot avoid. And how do you program this into a machine? Okay, when we go further in the slides, I will give you some other example as well. But this kind of artificial intelligence is extremely hard to achieve, and we are still very far away from it. I would say even with the current artificial intelligence and machine learning, we are just scratching the surface. We're not covering the full spectrum. Okay, there are intelligence. For example, these projects you might know already, this brain initiative, good artificial intelligence, MetaMind, DeepMind, Google DeepMind, that somebody like many of you might already know, the AlphaGo game, I guess. Yeah, there's some game that was won uh, by this DeepMind project, and there's some Blue Brain project, and there's so many other projects as well. People try to imitate and use this artificial intelligence for the betterment of humanity and not the other way around. If you want to have a more clear picture of artificial intelligence and machine learning, although they are used interconnected, interchangeably, but there's certain difference between them. In machine learning, for example, we can do object detection, and in artificial intelligence, we have this function of autonomous car, which includes object detection. So you can take artificial intelligence as a whole, and you can take the machine learning as a component out of that. But why this learning is important? Why do we introduce machine learning in any kind of application at all? There's some driving factors behind learning. First one is complexity in data. Go back to the slide where we discussed how much data is produced every single minute. How much data is produced by autonomous car? Do you know that autonomous car can produce about 6 terabytes or around about 6 terabytes of data every hour? 6 terabytes of data means that the biggest hard drive we can have in our home computer is, I think, 1 terabyte or 500 gigabytes, right? 6 terabytes per hour. How exactly are you going to process that data? Second one, human intuition is really hard. Why? Because if you are looking at a log file from a network, it will give you headaches. Trust me, it will give you headaches if a file is a gigabit long. And it is actually. So it will give you headaches. Like you cannot concentrate on that. Third one is scarcity. Scarcity comes in different flavors from the data. For example, sometimes you need data to decide on something, but it's very hard to achieve. And fourth, but not the least one, is changing pace of cyber crimes. There are cyber crimes of type which were never anticipated before, and they're very sophisticated now. So you have to evolve with their mindset as well. So that is why these are the 4 factors, but they're more important to think about why exactly do we need learning. So if we combine artificial intelligence with cybersecurity, we can have this artificial intelligence safety and security, which is better of the 2 worlds. Okay. In science and engineering, the potential and primary aim is to create safe and secure machines. So that if it is not the aim, that should be the aim. Now coming to the real topic that we started in this talk, machine learning in security. Why exactly do we need machine learning in security? And what exactly does it mean to use machine learning in security? This is the definition from Avera. There's so many different definitions, but this one is which appealed me, which is the development of computer programs with the ability to identify and block new and emerging threats more quickly. It means that if you put machine learning into the ingress router of your network, huge corporate network, that it should identify and block new threats more quickly than human being. Because if there's an administrator, he cannot do it in a real time, almost real time. Okay, so there should be automated program that should do it for you. For example, an assumption X is tested against data and result Y is obtained. This is what we do with machine learning. And Y is continually updated with new data, and the result of this brings us back to the new X. And this cycle repeats. So you have you have a result Y, okay? And then this Y is continuously updated with new input. And at some point, this Y is so intelligent, okay? Not intelligent, but so accurate that you want to keep it. And the whole process in between is what is called learning. So this is how we use it in a very simple terms. Of course, it is more sophisticated than that, but it boils down to this practice. Okay. Now, the whole process here is to focus on some kind of automation. Okay, and there's some sophisticated viruses, for example, malware, there are adwares, crimeware, spywares, worms, rootkits, trojans, viruses, and you name it. And you can use artificial intelligence for that, and you will generate the results that will favor your firm, that will favor the research community, and so forth. And people are doing that. To give you some examples from the past, in year 2000, there was a virus called I Love You. Okay, it affected 500,000 users, and the financial impact was $15 billion. It is humongous. It's huge. There's one code red in 2001. My Doom in 2004, Stuxnet, one of the most sophisticated ones. You might already know Stuxnet, that brought down the Iran's nuclear power plant. And Stuxnet, if someone of you already studies Stuxnet, it's extremely sophisticated. It becomes dormant. It's so intelligent that it sees the situation to act or not, to sleep or to act. It's that much intelligent, and it can hide itself. And most recent, not most recent, but fairly recent one is Heartbleed. Probably some of you might already know. Well, the financial impact was literally tens of millions, and it affected about 2/3 of the web servers. Okay, and why was it? I mean, what was used as a attack vector? The open secure socket layer flaws. So SSL security flaws were used to launch this kind of attack. So there's so many sophisticated attacks out there. We can take artificial intelligence as a use case, sorry, Internet of Things as a use case for artificial intelligence, because you can see that lots of resource constrained devices are used in in Internet of Things, and they do not have the sophisticated security techniques. For example, if you are using a sensor for your microwave oven, can you imagine to use very sophisticated cryptography to secure the communication between your sensor and the sink that is getting the data from your microwave oven? No, you cannot. So those are already vulnerable to so many other attacks. Whichever thing is connected to internet, it's eventually vulnerable. So, and the data produced by these things is also huge. They can produce like gigabits of data every hour, or even terabytes of data every hour. So where are you going to store that data, number one? How are you going to process that data, number two? How you're going to visualize the data, number three? And how you are going to take decisions on that data, okay? You have to think from that perspective as well. How does machine learning help in certain scenarios? Well, for the first part, you can just predict problems based on prior solutions. And you can use the ability of NLP to analyze unstructured data. And then you can have unique solutions and detailed insights to quickly stop intrusion or even prevent them in the first place. Okay, if you have enough data of your network traffic, you can profile users based on their behavior. Let's suppose you have this financial activity daytime in the stock exchange, and you're monitoring the network, and something happens after 6 p.m. or 5 p.m., which is not office hour, right? So there should be something going on. Or time-based, but there's some other techniques as well that you can use. So what artificial intelligence can do is to learn from the experience and then use that learned learned environment, I should say, to predict and to prevent something that will happen in the future with certain probability, I should say, because it's not perfect always. So we can have predictive analytics, which is used to detect anomalies in the network patterns, network traffic, and normal user activity. For example, if you have banking traffic and there's some users that are doing transaction every day, every month, let's say, for, let's say, 10,000 rupees, and suddenly that spiked over 1 million rupees a month or 10 billion rupees a month or something like that. And that should raise red flag, right? So you can do something like that. Well, there could be exploits that could be identified through signatures and patterns. Signature by signature, I mean every code has its own digital signature or patterns. So they could be analyzed, and we could be able to identify intrusion without having a prior signature. As I told you, the zero-day attack means that this attack is launched for the first time. You have literally no idea, okay, that what kind of techniques was used to launch this kind of attack, but through learning, we can have at least an idea. Okay? And there could be like behavior analytics from the social media and so forth. Well, it all boils down to this gut feeling that we human beings have. So, in a layman term, we can call artificial intelligence and machine learning to have this gut feeling, okay, and to have this predictive ability about what might be an attack. Well, you're not sure that whether it is an attack or it's a false positive or it's a legitimate act. You don't know. But if, for example, the possibility is brought upon to you, you can at least act on that, on that information. So this is the best that we want from machine learning to be in the cybersecurity paradigm. Well, I've been repeating this again and again, but network size is a monster because it's huge, so huge. Only superhuman can predict and not a human. So unfortunately, we don't have a superhuman. We have to depend on something with that. Advanced persistent threat, I already talked about Stuxnet, which is a bad news for us because the more you fight against it, the more it becomes intelligent. I mean, what are you going to do with that, right? So you need to have certain sophistication in your predictive analytics as well. So the moment you try to mess with the code, where, for example, the Stuxnet virus was, it just becomes dormant. It doesn't do anything. It camouflages into the normal code and so forth. So you have to be careful about that as well. There's a basic phenomena that we call URL. You should understand first and then reason on that understanding and then learn. Well, in understanding, what exactly do? You just examine the volume of data, huge volume of data, and then reason, provide insight based on your analysis. What kind of attack may occur or may have occurred already, you don't know. So this is what machine learning can do for us. We as a human being are reasoning about the things that could be done, and we then implement machine learning in the same sense. And the third one, the last one, is learn. It means that you have new insights that are continually created based on the new information that comes in. So remember the definition of machine learning from Avira. This is the exact same mechanism that is being used. So, well, all these things are really beautiful. They could do a lot of good stuff, and they're doing. But there's some bad news that I want to bring. In cybersecurity world, we hate something the most, which is some of you might already think what I'm talking about, but this is false positive. False positive means that, well, um, take the COVID-19, for instance. How many false positive were there? A lot, literally a lot. Okay. The same way we have false positive everywhere. Whenever there's machine learning involved, there could be false positive. Means that there was a legitimate attempt on the network, okay, and it was flagged as an attack. And let's say the service was closed, port was closed, technically speaking, but it was false positive. So we literally hate that word and we dislike that word, false positive, but eventually we have to live with it. And there will be always and always this false positive. And it wastes a lot of money and time. Um, Another challenge is that what do you exactly mean by normal behaviors? Because you can think about abnormal behavior only when you know the normal behavior. Okay, so that is also very important. If you have abnormal behavior that is predicted as abnormal behavior, it's true positive. This is what we like. If you have no abnormal behavior and it's predicted normal, it's false negative, then this guy here, the normal behavior is predicted as abnormal, this is false positive. And if it is a normal behavior and it's predicted normal, it's uh, true negative. Okay, I think there's some, yeah, okay. So we will be talking about it in a moment, but you have to understand that you need to have this normal behavior in the back of your head to work on the abnormal behavior. Uh, well, artificial intelligence and cybersecurity, it aims at weeding out the false positive while taking into account the context, and it always learn, and the result from the security system could be fed into AI and making it even smarter. So this is the architectural part that we'll be talking about. What you can do is that you can take the results from the security system that are already in place. This is the question of whether the existing system will replace artificial intelligence or they will live together. So what you can do is that you can take the output from existing systems, you can feed it into AI, and it will become even more smarter. IBM, on the other hand, it identified some new trends in cybersecurity, which are ransomware. I already talked about it. Second one is the application development in cybersecurity. For example, if Internet of Things is involved, then cybersecurity must be part of the software development cycle. Like if you talk about cybersecurity, is always the afterthought, right? So it should be the part of software development cycle in the first place. Third one is the deep learning to detect domain generation algorithms. It means that this domain generation algorithm, they're based on pseudo randomness. For example, people are using bots, means that automatic devices to launch the threats and not the human beings. That is even more challenging. So deep learning should be or could be used to detect these domain generation algorithms as well. Fourth one is detecting known malware threats. For example, using vulnerabilities in web browsers. Most of you might know OWASP, Open Web Security, some project. They release top 10 vulnerabilities in web browsers. For example, SQL injection, broken authentication, and so forth. And training, for example, neural networks and using machine learning algorithms to monitor normal behavior, and training this artificial intelligence about what is normal and what is not. So it learns even about that behavior itself. Okay, if there's the behavior and the system works, you can call it normal. And when the system deviates from that behavior, that will be called abnormal. So for human beings, is that we can employ machine learning for that. We can have honeypots and honey tokens. For example, you might know about trap. What trap does is that if you set up a trap for, let's say, the rat trap, the same concept is used for malware and some kind of attacks as well. Honeypot means that you put honey in it and they will come to eat it, right? So the same thing. What we do in cybersecurity is that we, let's say, in database, we create a table with the keyword like credit card numbers, let's say, or username and password. If that table is being accessed, means that there's some kind of attack, some kind of attack. There's sandboxing. Sandboxing means that you create an environment, a separated environment, where you test, you have the malware code, and you test the working principles of that malware in that sandbox and see how it is working. Okay, so you can do that as well. Okay, and the sixth one is you need to know how neural network works. I mean, do we really know how a neural network works? Do we know? Unfortunately, the answer is no. We still do not know how a neural network works because the number of layers involved are deep, okay? And we cannot exactly tell how the information is passed from one layer to another layer and how the information is processed at each layer and so forth. So it's very difficult to explain what is happening. We will talk about this term in a moment, but this is another way to look at. And these are the new trends in cybersecurity as well. Seventh one is employing capsule networks. For example, convolution networks, they are the revolutions in image recognition, and they are layers that filter the data flowing between other layers. For instance, if there's a network to recognize an image, let's say, what this network would do, it would find edges in the in the image, and then it would recognize shapes, and then finally objects in one image. But these convolution networks do not understand where those objects fit, right? For example, legs and arms can be recognized, but not more information than that. Okay, so what capsule network is, it's a network where neurons in each layer, they are divided into some capsule and they represent different properties of the same entities, let's say.
मैम मैंने ज्वाइन करके देखा, मैं तो कर पा रहा हूँ अभी।
Okay.
मैंने अभी जस्ट मोबाइल से ज्वाइन किया था आपने, ऐसी दिक्कत नहीं है।
Okay, so these legs and arms from previous example that we talked about, they can be recognized and put the arm in the place of arm and leg in the place of leg. As I said, convolution network could recognize these images for you. Some parts.
नहीं वहाँ पे वो नहीं है क्या, मुझे बताइए क्या नाम।
I'm sorry.
आपने क्या डिस्कनेक्ट किया था क्या?
The host, please. Could you please mute? Okay. So we can detect these objects, but where to put those objects, probably there is not enough data about it. So this is how,
लैन नेटवर्क कोई नहीं है वहाँ पे?
excuse me.
नेटवर्क कोई नहीं है वहाँ पे?
Hello. Host, please.
वैसे ऐसे सेशंस पे ना वो लाइव नेटवर्क पे ही जाया कि लैन नेटवर्क पे जाया कीजिए, मतलब वाईफाई पे मत ही कनेक्ट किया कीजिए। अब मैं बोल देता हूँ एक बार फिर से, आप चेक कर लीजिएगा।
Hello.
जब वो आएंगे ना उनसे बात कर लीजिएगा, बट अभी आप मुझे लिस्ट में नहीं दिख रहे हो।
Hello. I can hear the host.
नहीं, इतनी जल्दी नहीं उड़ता ये। ये तो लॉकडाउन में मेरे पास 1.5 GB होता था, दिन
Could
भर
someone
सेशंस रहते
please
थे,
tell the
जल्दी नहीं
host to
उठता ये।
mute?
नहीं नहीं नहीं।
Okay. So this is how the image recognition works. There are different, for example, layers. Then there's some fully connected layers and so forth. I'm not an expert in object recognition, so forgive me if I'm not being able to explain in the way it should be. But the people who are experts in object detection and recognition, they can understand what this figure is about. And then there's deep reinforcement learning. This is another trend in cybersecurity. What deep reinforcement learning is, for example, training a dog with treat and punishment, which is reinforcement learning. You have heard or you might have seen canine units, the dogs that sniff the drugs. So this is how they train them. They train a dog with a treat. If they predict or if they detect in the right way, they get a treat and they get punishment otherwise. And this DRL has more layers. It has more depth if we talk about the computer side of it. There's Q learning, which has a lot of role in cybersecurity. For example, you can put a robot in a building and tell it to find a warehouse, and that's it. No more information. Tell a robot to find a warehouse. Now, this robot will wander till it finds a warehouse. It will be um, attempt and error. If it has done it enough times, it will find even the shortest path. So it depends on how it does it. Okay, so this is the beauty of deep reinforcement learning as well. We can protect the IoT with the machine learning because the number of devices and family of devices, they are huge, they are so heterogeneous, and the data volume and data in its volume is so huge that without machine learning, it will be, if not impossible, extremely hard to achieve the cybersecurity. And you can, for example, predict the future as well. Well, in the investigation of cyber threats, let's say we can use cognitive computing. Cognitive computing means that it imitates the human behavior and human brain working principles. And then we can also use machine learning deep learning for crimes, to predict crimes before they happen. For example, in Facebook, on Twitter, and other online social networks. So we can use machine learning and deep learning for those scenarios as well. Okay, we talked a lot of good things about machine learning. Then actually, the attackers, they can be ahead of us as well. There's another part of machine learning that is called very interesting one. It's called adversarial machine learning. Means that the adversaries can also use machine learning and artificial intelligence. One should wonder why and how they can be used. Okay. So to make it easier for you, what the adversaries can do, they can learn the approximate machine learning model, and then they find the bias in machine learning model through interaction with that model, and then defeat machine learning through the corrupted inputs. Okay, so if you know what machine learning is going to do with the input, and if you craft that input in a way that it produces the desired output for you, means that you can use it in an adversarial way as well. Okay, this was the deal breaker a couple of years ago, where you have a sticker on the table, and then it was classified as so the classifier input was this one, and the classifier output was this one. Like it was with the almost 1% probability that this is banana. Okay, so this was the original one. Now here, if you have a crafted input in a way such thing like the classifier output was a toaster. I'm sorry, I forgot to put the reference into this, but this is from a well-known paper. Okay, means look at the image here and look at the classification here. So image is banana, and this says that this image is with like I think 90+% a toaster, and the probability or the classification output of banana is about 2 or 3%. But look at the image and look at the classification. Why this happens? Because after all, these are machines. And if you can craft input in a way that the classification is wrong, then, well, you can look at the result here. You're doomed, right? And here, if you can have a noise, a very intelligently crafted noise, then here is the panda, which is with 57.7% confidence, which was classified as panda. But after introducing this noise, it is classified as gibbon with 99.3%. It's the same picture, but with a little bit of random noise, crafted noise. Okay, so this is again from 2014, but this is a deal breaker. You might know Ian Goodfellow, which is the inventor of the GANs, Generative Adversarial Networks, that we'll talk a little bit about. But what I'm trying to say is that machine learning is not all noble. Like adversaries also know how to use machine learning. Now we have two fronts. Well, we started our journey with what exactly cybersecurity is. Then we talked about the networks that we have, the applications that we have. Then we talked about the need for machine learning. Well, we were happy that we can use machine learning to do stuff for us. But now this. So it even worse, it makes the matter even worse, right? If machine learning can be used in this way, imagine if it is a life-threatening situation. What will happen then? What if this kind of thing is implemented in, let's say, autonomous cars, right? So it will make the matters even worse. And then there's some other behavioral attacks. For example, there's a business email compromise. You get an email from your CFO to wire some money to somebody, and then the email from header is your CFO. And your suspicion, and you call CFO, but your phone is compromised as well. And you connect to adversary speech bot with CFO voice. It's very like science fiction situation, but it really happens. Okay, so if this kind of attack happens, then you're doomed again. Okay, and another thing on the adversarial machine learning is that it is used to dodge machine learning, and it is also used to hide information. And you might have heard about one pixel perturbation to fool neural network. I might have an example of it, but I don't have. So one pixel perturbation means that you have an image that is classified as banana with 99.9% probability. And even if you change one pixel at the right place, you can fool that neural network and it will classify something different for you. It's enormous and it's scary, but it happens. And there's so many other examples as well. So the bottom line is that adversarial machine learning is real, and we have to think about that part of machine learning as well. Generative adversarial networks is also a part of adversarial machine learning. It is called one of the brightest ideas of this century. Okay. How does GAN works? It's a generative model that is trained using two neural networks. One is called generator and another one is called discriminator. It was developed Google. And what exactly it does, it learns to differentiate the generated sample from the real sample. So what you do is that you have two neural networks, they sit against each other. One generates samples and the other one says whether it is generated or it is real. So the first neural network, it shares both sample, and the other one identifies whether it is real or generated. At the end of the day, what they're trying to do is that one neural network is trying to fool the other one is trying to not be fooled by the first one. It's very tricky, but if you think about the idea, it's the most bright idea of the entire century. Why? Because it has applications in almost every part. How? For example, if you take about the malware that we talked about, okay, you can train your model in a way that it becomes so strong that it recognizes real malware for you. Okay, so they compete against each other, try to fool, and thus become stronger against each other. And there's a point where these two models, they become equally, what we call diverge. So they diverge and they cannot become more stronger than that. So this generative adversarial networks has application in all part of life, and we have them in cybersecurity as well. So we have all these things. What now? Well, despite these concerns about machine learning and AI, future of cybersecurity is highly dependent on these advanced techniques. Why? Because without this, the factors that I talked about, the volume of data, veracity of data, variety of data, without this machine learning and deep learning and artificial intelligence, we will go nowhere, because it surpasses the human capabilities. That's why um, we have to rely on something. But having said that, artificial intelligence and machine learning, it's not a silver bullet. It means that it will not solve all our problems, but we have to use them in certain contexts. Where do we use machine learning and artificial intelligence? Just to revise, we use it in IDSs, intrusion detection. We use it authentication, authorization, access control. We use it in distributed DOS. We use it malware. We use it in eavesdropping, jamming, and you name it. There's so many others that we can use it. But the idea of using machine learning should be clear, that how does it work, so that we can think of application space where we can use this. But okay, everything is going so far in a good way. How does artificial intelligence work? Like, it's a very rhetorical question, but how does it work? The good news is that, well, we can think how it works, but the real answer is nobody knows. Okay? The next question you should ask is that, how come we have been spending an hour and a half about something that we don't know how it works? But this is what it is. Okay. Why do we care? So about this question, how does it work? How does artificial intelligence and all its family and friends and everybody works? Why do we care about this? Imagine a mission critical application, for example, IoT in healthcare and using machine learning for decision. Decision taken on nuclear power plant and some critical infrastructure. Okay. For that, the white box concept is necessary. What do we mean by white box concept? If you write a program from the start of this talk, I told you to write a hello world program in C language. You know exactly what is happening. You know which command is being executed, how is it compiled, how the memory is allocated for certain variable, and how it is done, and how it is bring to input-output devices on your screen, and how it is printed, what kind of ASCII characters are printed, and so forth. You know every bit of detail about that. But how about deep learning or neural networks? Do you know what is happening? Nobody knows. So imagine if you're using this machine learning in a scenario where there's a heart transplant or something, and you're not sure. Okay, so it means that we need a white box concept for certain use cases, which is not present yet. There's another field of artificial intelligence that we called explainable AI, or we call it XAI. What is it? Now we are moving forward from the simple artificial intelligence to XAI. It is a set of tools and frameworks to help you develop interpretable. The term interpretable is extremely important, and inclusive machine learning models to deploy them with confidence. So you want to deploy a machine learning model, but you have to be confident that it will work the way you want it to work, right? Otherwise, it has no use. As I told you, imagine a transplant surgery by a robot. How much you can trust that robot? You have autonomous car that is speeding on a highway at 120 kilometers per hour. And you have implanted medical device in a human body and that reacts something that could even kill you, God forbid. Okay. So you need to have this interpretable system. Imagine you go to doctor, you tell all your symptoms, and then you have this discussion with the doctor, right? So what is happening? He asks you some questions, and then you can have discussion. He explains to you everything, that what is going on, why your blood pressure is high, why you have pain, why you have fever, why you have sore throat, and whatnot. But you understand the interpretability of a doctor. So you want to have the same thing in artificial intelligence as well, right? But we didn't have this, and it came like recently, fairly recently, I would say in the last decade, that we should have this interpretability as well. Well, to understand that, you need to understand the stakeholders. So what are the target audiences? For example, they're domain experts and users of the model. Let's say medical doctors, insurance agents, and so forth. Why do they have this XAI, for example, to trust the model itself, so to gain some scientific knowledge? There's some other audiences or stakeholders. There is some, for example, users who are affected by model decision. Okay, there's some regulatory entities, there's some managers, there's some data scientists, developers. So all these people, these stakeholders, look at the artificial intelligence and machine learning from different perspectives. Then a subclass of this explainable artificial intelligence is what we called fairness in artificial intelligence. To understand the fairness in artificial intelligence, we have to understand the myth of bias. We as human beings, we have the bias in our genes. No matter how we try to avoid it, but we still have bias. I'm a little bit reluctant to give you examples, but these examples are published. Those are documented, so I will give it to you. For example, machine learning techniques were used to find the crimes in certain countries like United States. Would you imagine that colored people were more so the machine learning schemes were more biased towards colored people, okay? And the rates of crimes were even more like detected more, with of course with false positive, but I'm talking about bias here. There's another very good example that you should understand is quick draw game. So quick draw game is a very good example of this fairness in artificial intelligence. For example, it is extremely critical to engage with the diversity of perspectives. When you test a product, let's say, you have to take the diversity into if there's a game like this quick draw game, there are people who were asked to, let's say, draw a picture of everyday things like shoes, okay? So the people were asked to draw the picture of a shoe that we wear, and that will be used to train a model. And what happened is that most early users, they drew shoes that look like sneakers, let's say, or the shoes that they wear. And when more people interacted with this game, the model was not able to recognize any type of shoe that wasn't a sneaker. How come? So people drew shoes in different ways, okay? And it was used, to train a model. And when this was input, it kind of recognized it. But when this was given as input, it didn't recognize. It means that the bias of people towards, let's say, sneaker-like shoes were more than this-like shoes. Okay, it means that you have to take diversity into account as well. So the fairness in artificial intelligence is extremely important. Why I'm talking about this? If you put this into the perspective of cybersecurity, means that you have not to be biased, and you should not be biased towards one certain behavior. Okay? So you have to take the whole picture into account. Now there's another side of the story. I will finish my talk with this. I'm almost finished. I'll open to questions after this. But there's always the other side of the story. So currently, I was working on a project on this explainable artificial intelligence with the University of Manitoba, Canada. But I personally ran into another question that kept me thinking, do we really need an explanation? I mean, well, there are cases where we need explanation, but the question itself, explanation, is it mandatory? Is it necessary? It's more like a philosophical question, but you still have to think about it. I'll share with you an experiment from NeurIPS, which is a very popular conference in neural networks and machine learning. Some of you might already know. There was a test from the audience. They were told that there's a critical surgery of a robot with 3% chance of dying, but no question asked from the robot. Means that the robot is going to do the surgery for you, and you have 3% chance of dying on that table. But you cannot ask any question from that. The same surgery can be carried out by a surgeon, a very experienced surgeon. But the doctor can explain everything to you. I forgot one thing to mention here, that the surgery by human being or a surgeon has 15% chance of dying. Sorry, it was 15 or 13%, I forgot. But there was 10% difference. So 3% chance of dying by robot, but you cannot do you cannot ask anything. It will be just you sit on the table and then the robot will do surgery for you. On the other hand, the surgeon, the surgeon, he or she will explain every single thing to you. He will coordinate with you. He will explain everything to you, but the the chance of dying is 15%. Now, which one would you choose? Would you give your life, like, would you give the trust to a robot with your life? Question number one. Would you rather trust the explanation by a doctor rather than, you don't want to take 3% chance, but you want to know everything about your situation and then the doctor can do it, or the robot? I will leave this question open for you. But just think that there's always other side of the story. So which one would you choose? If you want to know the result from this, most of the people, they chose robot from that NeurIPS. I guess it was 2018 competition if you search about it. It was a NeurIPS 2018 conference, and they did this human experiment. But it kept me thinking whether if I was there, would I choose robot over human being, or I would choose human being who could interact I mean, so I hope you got the whole picture. So by here, I will stop and I will just discuss some takeaways for the people who want to continue research in this direction. Well, there are a lot of opportunities in machine learning and deep learning. There are lots of challenges that still have to be addressed. The stakes are high, very high, and you don't have to reinvent the wheel, of course, but you can make the existing wheel efficient, okay? And AI and machine learning are not only good for us to use them, but they're good for attackers too. You have to be very careful about that. Well, you can use the expertise from both security and machine learning. As I told you, I personally am not very good expert in machine learning, but I started to look at from the security perspective. And AI and machine learning, they are not silver bullet. Um, the combination of human intelligence and artificial intelligence will prevail. And then there's this explainable AI as well. So it is not that only one thing will work, but the combination of these things will work. I thank you so much for your patience and bearing with me for 1.5, an hour and 40 minutes. Thank you so much. I'm open for questions if you have any.
Thanks, Rashid. It was really very informative session. And if attendees have any query for this session, they can put their questions here and Rashid will reply. So anyhow, one person is asking, Sonam.
Yes.
Sonam is asking, what is the future of homomorphic encryption?
Yes. So it's a very good question, I would say. The future of homomorphic encryption in AI. I personally didn't look at it. I was looking at homomorphic encryption as a standalone topic, but of course it's extremely important to think that AI will dominate in some ways, from which I understand the um, I'm sorry, just give me 1 second, please. So homomorphic encryption will itself, I mean, we are still a long way to go with homomorphic encryption because it's very difficult to, to realize even in today's world. But if we use artificial intelligence, the things that I can think of is that the contexts come into picture, okay? If you're doing data analysis on encrypted data, then artificial intelligence can come into picture to learn from that data, okay, and then use the right homomorphic encryption for that. You might know that homomorphic encryption is not only with addition, multiplication, but there's a division and other things as well. So for that, what we need to do is somewhere in future, right now I'm not sure, but somewhere in future, we might be able to use the services of artificial intelligence to learn from the patterns of the encrypted text and then use the right function of homomorphic encryption ranging from very basic level to a very sophisticated level. So this is what I can think of right now. In the near future, we would be able to do that. At the moment, I'm not sure if there's anything that exists to 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 study the analysis of encrypted text with artificial intelligence. Right now, I'm not sure if there exists any, but in future, I'm sure there will be. Okay.
Rashid, there is one more question. That is how our IoT can be related to VANET, and
Yeah.
what will be the methodology used for it for
So,
AI? How AI?
oh, okay, great. So, Internet of Things, I would say that Internet of Things and smart city it's a whole paradigm, it's a whole ecosystem, I would say, and IoT is part of it. Okay, Internet of Things is it's a fancy word used, means that what you're trying to do is to connect things into internet. The thing mentioned before. When we talk about Internet of Things and vehicular networks, we can use Internet of Things inside vehicular networks. For example, how? There's a system called in-vehicle network. We don't call it IoT for sure, but we call it in-vehicle network. In principle, that comes under the definition of vehicle network. Why? Because every component of vehicle is connected somehow to a bus, and that is connected somehow to internet. So by definition, it can be Internet of Things as well. But how do you connect to the real Internet of Things with vehicular networks? You can have smart home. Let's say I can give you an application example. You can have a smart home. You have a car. You're driving from your office to your home, and then you can use the system in your car to, let's say, turn on the AC in your home to make it cooler before you go in the Indian heat. Okay, or if you are in winter, you want to turn on your heater before you go home, or you can do such things. So there's so many different ways that you can connect vehicular networks to Internet of Things. Now the question is, how do you use artificial intelligence in that? What you can do is that you can, let's say, do the predictive analysis. For example, what you can do is that you can have sensors at home, and you can use that IoT framework at home to predict whether the batteries of your remote control are enough. Let's say, what is the humidity status at your home? I mean, where are you spending more electricity? Where can you save electricity and so forth? You can do this predictive analytics, and you can predict like the failure of a component. You can do a lot of different stuff. So there are so many open ways and possible ways that you can use these two technologies. Okay, so the
There
next
is one
question.
more question from IoT
Yes.
point of view. Where this learning and intelligence will be implemented? Will it be centralized or distributed?
Sorry, I cannot see the question here, but could you please repeat it?
Yeah, from IoT point of view, where
Okay.
this learning and intelligence will be implemented? Will
So
it be
from
centralized or distributed? Yeah, centralized or
exactly,
distributed? Yes.
a very good question indeed. Both ways. If you want to do it distributed, then we call it federated learning. Federated learning means that, well, privacy issue comes into picture here. When we use centralized machine learning, it means that you have to offload all your data to centralized server, let's say. That will do the analytics and stuff like that. But what if you don't want to share the data with the centralized server? If that is preserving data or privacy sensitive data. So you can use it both ways. If you don't need privacy, then you can use a centralized mechanism. If you want to use distributed, if you're privacy conscious, then there's a term called federated learning or distributed learning, where you do the computation and everything locally on your mobile phone or your mobile device, and then you only upload the statistics of model to the central server. Okay, so it's possible both way. It depends on your scenario, where, like, what kind of scenario you're dealing with. Okay, so it's possible both ways. Another question here I can see is that how many ways can we use IoT in designing smart city? Well, IoT is bread and butter for smart cities. In smart cities, you have everything ranging from street lights, ranging from road sensors, ranging from pedestrian, and so many other things. Okay, so IoT will be the bread and butter for that. And you can use analytics, you can use prediction and everything uh, based on the output of those sensors and those devices. Yeah? Okay, how can we use AI with VANET in terms of metrics and parameters? Um, VANET, and I would say autonomous cars as well. They're literally based on artificial intelligence, and if you connected car technology that includes, let's say, autonomous cars as well, that drives itself without a driver. Then the path planning, you know, autonomous cars, like if I give you an example, in my university here, we have 6 autonomous cars, 6 driverless cars. They use it as a taxi from Yandex. Yandex is Russian Google. They have their own driverless car. You can go and search online on YouTube. You can go and see Yandex autonomous car or Yandex car in Innopolis University. They've been driving here for almost 2 years now. So what they're doing is that they're getting their self familiar, the cars, they drive themselves on the roads. They want to learn from the experience. Okay, so the artificial intelligence and learning is bread and butter. Without it, you cannot implement this whole system. So it's the integration, so it is integral part of the whole autonomous system scenario. And same is true for connected cars as well. Like if you drive, if the cars are communicating with each other, then let's say there's so many applications. For example, if there's a black ice on the road or if there's a road work, of course, in connected car technology, your car is supposed to generate a warning message for all the incoming vehicles. But how does they do that? They can learn from the behavior, they can learn from the environment, they can learn from any other um, uh, nodes in the vicinity and then generate a message out of it. So the question of how can we use AI with OneIt is it should be replaced by where we can use and where we cannot use. So there's the place where almost everywhere you can use artificial intelligence in vehicular networks and especially in autonomous cars as well.
Rashid, there are,
Yes.
I'm looking at the questions and there are no more questions. If there will be some
Okay.
questions, attendees can share with their emails and I'll
Okay.
forward it to you. Okay?
Sure, sure. No
Thank
problem.
you.
No problem at all.
Thanks for the
Thank you.
presentation. Thanks you.
Yeah.
It went very smoothly. I really
Thank you.
enjoyed.
Thank you so much. Thank you so much, everybody, and thank you so much, Charlie, for inviting me. Thank you so much.
Okay.
Okay. Have a
See
good
ya.
day.
Bye.
Yeah. Bye.
Bye.
Bye.